Okay, this is where I would like your imagination to be at its best. One thing about this course is that if really in your childhood you didn't play with toys, it's difficult to understand embryology. Okay, because we have some rotational defects and everything that we expect you to imagine it. But don't worry, I'm going to give you a lot of videos to cover that part. Okay, and then also in infancy, you see, when a baby or when a toddler is playing with a toy, you see, they can see the toy doing a lot of things while adults cannot see. They can feed the toy, they can give it food, they can bath it, fight with the toy and everything. Okay, at times when they're at home, you think they are going crazy, but that is what we call imagination. They can imagine the toy doing everything, they will fighting with it. If you didn't play with toys in infancy, we're going to have a bit trouble with you here. But I'm going to give you a lot of videos to support you so that you need grass. Now you need toy be a toma you should okay, so I'm going to try my best to put you with those who use toy everybody in the same plane. Okay, and when we talk about fertilization, what is actually fertilization? I know you're going to tell me fusion of sex cells and you are done. Okay, but it's more than that. Remember, let's go through a quick revision of the male and the female. You see, the male, I was interested in the testes because of the sperm cells. Can you tell me the journey of the sperm cells till it reaches the oviduct? Who can give me that summary? The journey of the sperm cell till it reaches the oviduct. Yes, anybody? Start from ejaculation. Yes, anybody to try that? From ejaculation. Yes, as I said, roots, ayaba. Fertilization is a fusion of male and female cells to form a zygote. What can I call the baby? Oh, Gladys, where is she? My dear Gladys, are you there? Gladys. Hey, this was experiencing morning sickness. Okay, quickly, who can summarize the journey for me? From ejaculation to the oviduct. Come on. No one to try? Oh, before mass in camp one for 5 marks. Yes, free 5 marks. Who will try? Hey, yes, Antoine be any page in this one. There's no Yes Antoine here today. Hey. Akosha Mansankwa number 1. No Yes Antoine on the page. 561 students. I'm supposed to get 1,000 something students. 561. No Yes Antoine in it. And I'm nobody. Nancy, course rep. We are not about Perita. Now about a course reps for Nina and boom. And then I'm answer question. So Bianca Sadia will have answer. Nancy, give me the journey. Or you pass it to Perita. Or you have the right to pass it. Pass it to Perita. Okay, Perita, it has been passed to you. You? To who? To Sarah. Okay, Sarah, it's your turn now. Sarah. What the passing will be in you? Course reps Nasa. And I bisa also. Okay, let's quickly go through that before the course rep pass it on and on and on. Now, during ejaculation, we said that the semen is a base, a pH of 7.1 and above. Okay, it needs to be a base because the vagina is acidic. Okay, so when ejaculation it pours into the vagina, they are supposed to dilute the acidity of the vagina, such that those sperm cells that will be poured in later will be able to swim through the lake of fire. So that's the first aspect. Now, the cervix of the female is very narrow. So having millions of sperm cells focusing on the cervix, by all means, some of them will crash on each other, others will die. That place becomes survival of the fittest. So the sperm cell need to pass through the narrow opening of the cervix. But when you get to the large space, that is the uterus, there's a problem. The uterus is infiltrated with white blood cells, macrophages. These macrophages will engulf, will attack and kill the sperm cells. And then, you see, so the sperm cells have to run for their life. So, whilst running for their life, the sperm cells should be able to detect either the oocyte is on the left or the right side. If you make a mistake, if it's on the right, you go to the left, you die there. Okay? But if it's on the left and you're able to go to the left, when you reach the corner of the oviduct, that place, there's no white blood cell. That's the first place you can rest. During that time, if ovulation has happened, I hope you know how ovulation happens. Under the influence of LH, the Gravian follicle becomes turgid and it is splashed open, leaving the oocyte. The oocyte coming will be whipped by the fibrin into the oviduct. Remember, when it's whipped into the oviduct, the oocyte is not alone. We have granulosa cells around it. We have ZP around it before we come to the oocyte. So it's not like the oocyte is empty coming. It's protected also. Now we have the oocyte in the oviduct, and then we have also the sperm cell. It's also in the oviduct at both ends. Now the peristaltis movement of the oviduct to push the oocyte, and also the cilia movement will also push the oocyte up and down. That's how the oocyte comes forward. Remember, the peg cells is not free. While the sperm cells will try to dodge 1 or 2 or 3. Now, when they meet the oocyte, they have the first barrier. The first barrier are the cells around the oocyte. Passing through these cells needs a vigorous enzymatic action. Now, if you're able to even pass through these cells, you don't go alone. You meet ZP. Remember, we said ZP, we have 4 types. ZP 1, 2, 3, and 4. And we said 4, we don't even know the unknown. Now, the type of ZP that you attach yourself to will determine either you enter or you don't. Let's say the sperm cell is fortunate, attaches itself to a ZP to enter. Now, when it attaches itself to the ZP, there is a reaction that happens. Okay? There's an acrosomal reaction and also a reaction that will make sure that no sperm cell should be able to enter the oocyte again. When that attachment to the ZP happens, that is triggering. And then any other sperm cell that is going to the ZP will be killed. Just like a chemical reaction, killed everybody around. So that the only sperm cell that attaches itself will gradually release the DNA material into the cytoplasm. That is where the DNA material of the oocyte or the oocyte itself and the DNA of the male, that is where there will be a union. When that union is formed, is then that we say fertilization has occurred. Ladies and gentlemen, fertilization is not just a small job. The running, the marathon running, the dodging effect, the strongness and the survival rate of the sperm cell determine who or which sperm cell will reach the oocyte. Remember, there were about not least that 20 million sperm cells. If you are here today hearing me, it means you are a survivor. At least out of 20 million sperm cells, you survived. So at times when I hear people, at times I wonder, to even form you, there was a battle of 20 million sperm cells, and then you made it. So how can you be in a class of 50 and you think people can bully you? In a class of 100, a class of 1,000, and you are afraid. 20 million, you beat them, and you are here today. You should be proud of yourself to be living. Don't allow anybody to turn down with your life. You are a survivor. Okay? So fertilization to us embryologists, when you look at it, that is a survivor speed. Okay? So when you define fertilization, it's not just a meeting of sperm sex cells, as you said. It was a battle, a survival race. And the good news is that you are here today. So you see what fertilization goes through. So what we're going to do this morning or this afternoon is to go through the steps of fertilization. Actually, from the oviduct aspect. What happens? How is the sperm able to dodge all these peg cells? How was he able to penetrate the first barrier, the second barrier, and release the genetic material? So actually, the good news is this. Who we are more of our mothers than our fathers. Because apart from the DNA material released by the male sperm cell or the sperm cell, every other thing, protein, synthesis, mitochondria, everything was acquired from the oocyte. That acquisition is not for free. It means that whatever that is your mother's family, you have it. If your mothers are hypertensive, you are at risk. If they are diabetes, you are at risk. If they have breast cancer, you are at risk. Whatever they have there, you are at risk. That is the bad thing about it. But the good thing is that intelligence is not from fathers, ladies and gentlemen. The cortex of your brain determine the thick they are, the more intelligent you are. And this, we acquired from our mother. So how smart you are is not from your father. Your father can be the brilliant person on earth, but intelligence is exposure that he can give you, but intelligence is from the mothers. So ladies, you see what men we want now? Any scientific man does not want beauty. We want intelligence. Because the outcome of your kids determine of your wife, the intelligence level of your wife. Okay? So that's what fertilization is about. So fertilization is a whole game of itself. For me, when I'm dealing with fertilization, I see it like a war. Because I can see myself dodging 20 million sperm cells and I'm sitting here today. I could have been anybody, but I'm who I am. So that is one of the biggest fight that you never fought in your life, fertilization. So okay, we're going to go through that fight, then go into implantation. That is another mystery on itself. Okay? So that is how fertilization is about. So imagine fertilization in that manner. It's not just a fusion of sperm cell, as we said. It is a battle that you won. So be proud of yourself. That's the best thing I can tell you. Okay, yes. As for intelligence, men we know. But ask yourself, why can't women take over the world? And it's a word of men. There is something that happens, but I don't want to go through that. Let me focus on what I'm supposed to do today. Okay? Ladies, you are intelligent. Let me tell you what you use your intelligence for, quickly, without wasting my time. You see, in a relationship, when men are cheating, it's easy to know. A lady can fling their eye and know. But when a woman is cheating, you need God to tell you. You need God to tell you she's cheating. Okay? Why? Because the cortex of the brain is very maneuvered. Okay? So that's the whole concept. But there's something that happens to you through the puberty and this and then your intelligent level. Now, if you focus on yourself, can you remember that in primary school you were very good? Can you imagine that one? In primary school, now the first, who the second. Now, when you have there, I don't know what do secondary school, nursing training after there, what happened? Somebody that was 1 to 10 in primary school, what happened? Most of these gentlemen that time were 11 to 13. But as we are coming up the development stages, then we understood the power we have. This is where fertilization implantation goes beyond comprehension. So I'm going to take you to the depth of who you are. Okay? I'm not just teaching implantation or fertilization. I'm teaching you life. So that when you comprehend it, you know the value that you have and know what exactly you are and how to be with yourself. And one just what you home or be anywhere or be you when you are bibia wo manimra bonten when you beje. Okay? So that's my introduction for fertilization. Now let's go through the details. Now in fertilization we have stages. Okay? In fertilization we have stages. There are 3 events of fertilization. Look on the screen. 3 events of fertilization. Number 1, we have the sperm penetration and membrane fusion. Number 2, we have the egg activation. And number 3, fusion of nucleus. I think I've already explained all these things, but just that I did not tell this number 1, this number 2, this number 3. Okay? Remember I said something that when the sperm cell reaches the group of cells and touches the ZP, there's a chemical that is released to kill any other sperm cell there. That's the egg activation. Okay? So we're going to take through it one by one. Sperm penetration, fusion of membrane fusion, egg activation, and then fusion of nucleus. These are the 3 events. So when he asks you to briefly explain fertilization anywhere, where you find yourself, because in the exams I'm not going to ask you this. I've said it's multiple choice, so there'll be a lot of answers. But for your own good, we don't take this course and then think about exams alone. I'm giving you life. Okay, so fertilization has 3 events. These are the 3 events: sperm penetration, membrane fusion, and the next one is egg activation. The last one, the fusion of nucleus. Let's go through it one by one. Let's look at sperm penetration and membrane fusion. Okay. I'll prefer, you see, the sperm cell has an acrosome. Okay, the mouthpiece of the head of the sperm cell contain enzymes. Okay, and that part is called the acrosome. Okay, so when it says sperm penetration and membrane fusion, the penetration has to do with the sperm cell, the acrosomal activation. Okay, so we're going to go through all these things one by one. Let me get a picture to explain all these things in one. Okay, so sperm cells, the acrosome of sperm cells are covered by a membrane. When they are reaching the cells, the group of cells surrounding the oocytes, then these membranes are removed by certain chemicals. That is what we call egg or acrosomal activation. Okay, it's now ready to pour the enzymes and digest its way through. Unless a sperm cell has this activation, it can't digest anything. Okay, and they do that only when they are in contact with these cells. Okay, now when it comes to egg activation itself is something simple. If you've done basic tissue, we talked about calcium. You see, when calcium leaves cells and calcium entering cells, there are 2 different scenarios. When calcium leaves cells, the cells becomes a bit rigid. When calcium enters, they become soft. Okay, now in egg activation, we have release of calcium that initiates, so calcium leaves the cell, so automatically the ZP around it is activated. Okay, now this activation is important to make sure that only one sperm cell can get access to the oocyte. In other words, it's there to block polyspermy. Polyspermy means that 2 or 3 sperm cells enters the oocyte at the same time. So when one touches the ZP, there's an egg activation, making sure that all the other sperm cells around die off. Okay. So let's get the triggering factor. In egg activation, there are also 3 processes. Okay, so it's on the screen, you can look at it. Let me get a nice picture. Okay, now let's look at this picture to explain all what I said. The picture has 1, 2, 3, 4, 5, 6, 7, and the end. Now, if you look at one, we are saying sperm penetration between the granulosa cells. So you see, this is where the sperm cell comes in contact with the cells around the oocyte. It needs to eat its way out. Number 2, we have ZP degradation by acrosomal enzymes. This is what I said, that we have activation. This is where the acrosomes of the sperm cells are released to digest their way through the glycoprotein, that's the ZP. And then number 3, we have sperm and egg plasma membrane fusion. By doing so, the head membrane fused to the ZP at the same time. And number 4, this allows the sperm nucleus to dissolve themselves into the cytoplasm. So remember the steps very well. Okay, we have penetration to the granulosa cells. We have the enzymatic acrosomal activation to eat up into the ZP. And when that happens, there's a fusion of the membrane of the head to that of the ZP. And in that instant, we have another action taking place. Calcium leaving the ZP area, and then we have granulosa cells that are coming to solidify the ZP, also going beyond it and killing any other sperm cell, so that no sperm cell can enter the oocyte again. Okay, with all these things in place, we can still have polyspermy. Apart from all these scenarios to make sure no one enters, polyspermy can happen. But if polyspermy happens, the body will detect it and destroy it. If it's not destroyed, we're going to look at what happens next. Okay, so when the nuclear material is released into the cytoplasm, if you look on 5 and 7, 5 to 7, that's what happens. Okay, we have 7 is the sperm, and then the oocyte nucleus enclosing to form 1. This is where fertilization ends. So know the event of fertilization. Know the events of fertilization carefully. Okay? Any question on the event of fertilization? Any question on that? Any question on the event of fertilization? Is that clear? Or do you have a question? Okay. Silence means consent. It means we all gotten it. Now, when it fertilizes, I said something. I'm saying that when the DNA of the male is... Yes?
So, please, I have a question.
Yes, go on, go on.
So, please, two sperms fertilize the ovum at the same time? Like the same time this one is fertilized?
Yes. And I said, if it happens, the body will take care of that. Most of the miscarriage that you get, most of them that you don't even implant, is because of that. When it happens, the body will discard the zygote. It won't let it go through. If it even goes through, there's another procedure to make sure that it's eliminated. Okay? So we're going to look at it. If that baby is born, how do we call that baby? Having two sperm cells to one oocyte. How do we call? So we have X, XY. How do we call those babies? XXY. We call them what? I didn't hear that. How do we call them? Okay, let's go through. Don't worry. You said you call them what? Please come again.
He said
Hermaphrodite. Hermaphrodite. Not really. Okay. Not really. Okay, don't worry. It's in the PowerPoint. We're going to read that soon. Now, let's continue. After fertilization happens, when the sex cells, when the nuclei has met, there is one rapid division that happens. We call it cleavages. It's just like a mitotic division. Okay? Now, two has united to form one. Automatically, after fusion, then they started dividing. The two divide into, the one will divide into two, two into four, four into this. But this one, they don't detach themselves. Okay? The cleavages are like that of a ball. They divide, but they are still stick together. Okay? So cleavage is the rapid division of the zygote into a larger number of smaller and smaller cells called blastomere. When the big one is dividing, but it's all glued together, the small divisions that are coming, we call them blastomere. Okay? So get the terms right. That's why it's in red. Blastomere. So if you look at the picture there, okay, let's look at this one. Okay, after fertilization day 3, have you seen it? Look on the screen. After fertilization day 3, and then late day 5, have you seen it?
Yes.
So day 3, so that same thing, I'm going cell division, mitotic division, to form tiny or smaller cells. We call them blastomere. Now, this is not in the PowerPoint. Listen carefully. What I'm going to say is not in the PowerPoint. Now, the blastomere division have names. The blastomere division, they have names. When they divide into a 4 cell, the 4 cell will divide into an 8 cell. Okay? At the 8 cell, we say each cell is totipotent. Totipotent. This is the term. Totipotent. T-O-T-I potent. Okay? Totipotent, each blastomere at that time is totipotent. Totipotent means what? It means if at that time I'm able to separate each blastomere and implant it in a different person, each of these ones will develop and form a whole human. I'm repeating myself. 2 to 4, 4 to 8. At that stage, we say the cells are totipotent. totipotent means that each of these blastomia at that time can form one full human being. So if they are separated at that time, we can put one in each lady and they will have full babies. We say they are totipotent. It means each of them can form one human at that time. Okay? Now the division will go in. From 8 it will divide 16. 16 it will divide 32. When it from 32 going, we say it's pluripotent. Or from 16 going, we say it's pluripotent. Pluripotent means what? It means now each of these small blastomeres are forming one person. Now the blastomere here will be responsible to form each part of the baby. I'm taking that again. We have totipotent and pluripotent, and I'm explaining the two terms. When I say totipotent, it means that's up to the A cell division. At the A cell division, each blastomere is capable of giving a full human being if separated. But from the next division onwards, we say it's pluripotent. Pluripotent means that now each of them are contributing to form one person. So now the blastomere will be responsible for each part of the body formation. So in embryological lab, I hope you've heard people giving birth to 8 and over. Have you heard it before? So this is where it happens. If at the A stage all the blastomere become separated, each of them can form one human being. So that lady will give birth 8. But if they don't separate and they go through the next division, we say they are pluripotent. A pluripotent, it means that now they are all forming one person. I hope we are okay.
So the last statement again.
Pluripotent and totipotent. Pluripotent means that now from that cell division, they are all going to form one individual. Okay? So if you look on the screen, now whilst these cells is a ball forming, there is something happening in it. We are going to get some of the cells that will migrate to the ends and some of the cells that will aggregate and leaving a big space inside. This is a whole ball. Unless you make a cross section, you won't see this division. You see it as a ball, but actually inside there's something happening. What happens inside is that while it's dividing 4A, 16 going, inside there will be a space creation, a vacuum, a fluid area. We're going to call that fluid area the blastocele. And we're going to have other cells migrating to the cortex, to the periphery, forming a whole circle. Those cells will be called the trophoblast. And we're going to get other cells aggregating themselves, coalescing themselves, coming together at a particular spot. And we're going to call those cells inner cell mass. Remember, in all these divisions, we still have ZP around it. Okay? So this is what happens from fertilization before it reaches the uterus. So this one is when the fertilized ovum is undergoing division before it reaches the uterus. Okay, it will take approximately 5 to 7 days to reach the uterus. So whilst coming to the uterus, it undergo these divisions: 2, 4, 8, 16, 32. Whilst it's dividing that much inside that cell, this is what is happening. Some of the cells are moving to the periphery, others are aggregating to a whole spot, and then there's a vacuum created. The vacuum will be fluid-like substances. Okay, and then we call the vacuum blastocyst. And then those cells that migrate to the periphery, we're going to call them trophoblasts. And those that migrate together, stick together, we're going to call them inner cell mass. But remember, the ZP is still around it. Any question? So this usually happens at day 5, late blastocyst stage. Remember, I said the journey from the oviduct to the uterus takes 5 to 7 days. So at day 5, this is how the zygote look like. We have aggregation of blastomere at one end. We're going to call them inner cell mass. We have a fluid-filled space inside, that is the blastocyst, and then we have the trophoblast forming the periphery of it. Are we okay? Are we okay? We're on day 5. Oh. So we've done fertilization, we are now on day 5. Can I proceed? Is there any question?
Yes, sir.
Good. Now let's go to twinning. You see, implantation itself is a whole ball game. So I'll talk about implantation, but let's look at how twins happens. Now let's focus on the PowerPoint. There is A. You see A? So we have A going, we have B, we have C. So we have 3 scenarios that will form different twinning system. Let's start with A. A, you can see that the division, the union division has formed 2 different cleavages, and each cleavage is undergoing its own cleavage, such that they will form 2 different individuals. So one ZP here, one ZP here. They will all implant in the same uterus, but they have their own things together. That is A. Okay, so this is 2 different things. Now let's go to B. B, they will fuse. They will try to divide into 2, but they will stick together. So we're going to have a trophoblast around 2 inner cell mass together. So these twinnings will have something to share. They will share common trophoblast, common cord, common placenta. Okay? And let's look at C. C is like B, but unlike B that is fully separated, the C, they won't be separated. The inner cell mass will try to separate them, but there will be a link between the inner cell mass. When it happens like that, the baby will be born, but they will be fused at one part of their body. If their stomach is fused, there's a name for it. If their head is fused, there's a name of it. If their back is fused, there's a name of it. So this is where twinning things comes in. Now, if you look at A, what can you say about A? What type of twins are A? Look at A. Yes? Yes, Charlotte. Analytical twin. Thank you. So you can have male, female here. Okay? And then B. B. B will form what? Charlotte again? Identical. Is there any name you can give to an identical and identical twin? We don't pay down Sebi. Eh? We pay down Sebi. Ah, Sembe Preni. Why no? Why them pay down in Sano or Casano? Okay. Okay, so monozygote and then. What about C? C. Yes, any hands up? Or any testing? C? Yes. Fadila 2. D, yes. Fadila 2. Okay. Now, conjoined and Siamese is basically, let me say diploma, okay? It's basically diploma, okay? Come to the university. Find out the proper name when the abdomen is stick together, or when the abdomen and thorax are stick together, or when the thorax alone is stick together, or when their head is stick together, or when their back is stick together. We have names for each of these, ladies and gentlemen. Find the names. Okay? Co-joint is perfect, but that is for more of diploma level. Bring it to the university level. Okay? Thoracophagous twin. What about only their heads? Only their heads are stick together. Yes? How do you call them? Find the names. Okay? Find them. Now, let's go to how we've reached day 5. Now, from day 5, implantation can happen, but from here, things need to change before implantation happens. Okay, so let's look at the change that will happen before implantation. Okay, we call it hatching. The embryo needs to hatch. You see, all along, ZP has been around it. And when you have ZP around it, it protects you from the environment. It protects you to also to grow. So along the line, before implantation can happen, the embryo needs to hatch out of the ZP. When you do that, then it can grow his root well. It can easily implant in the endometrium and then have a firm grip of the endometrium or penetrate to the endometrium. If there is ZP, it will never implant. Okay, so in the lab, when we do the fertilization, we have chemicals, enzymatic protease enzyme that we release into the reaction to digest the ZP. When we do that digestion, then we can implant it or transfer it into the uterus of the woman. And that's one of the difficulties in embryology or in IVF, implantation. One of the trouble of IVF is what we are discussing, implantation. You can do everything nicely, and you can release them into the uterus. But for the embryo to implant, you can't do anything about it. Some of them will decide to implant, others will not even bother themselves to implant. If you're able to know why they don't implant and solve that solution, then IVF will be 100% solution for infertility. But we don't know that. We can do everything necessary, but implantation won't happen. We do the proteinase, we do the washing, we do everything, but that is why we say IVF is 50-50. The embryo can implant or will not implant. So that is one of the trouble. But we should remember that if there is no enzyme to digest the ZP, there is no implantation. So in the body, we have an enzyme that we call protease enzymes that will be secreted by the trophoblasts. Remember, the trophoblasts are the cells around the embryo. So they will secrete enzymes that will digest the ZP. After digesting the ZP, then the embryo now can crawl out of the ZP and then embed itself into the endometrium. If ZP is not removed, implantation is not possible. Okay, so read between the lines. I'm taking my time to explain this gradually so that you get the whole concept. Okay, so when ZP is not removed, implantation is never possible. So implantation can also happen in the oviduct if even the ZP removal happens. If the ZP removal happens, whenever it found itself, it will implant. That's why the ZP is removed usually the 5th day going, so that by that time we expect the traveling embryo to have reached the uterus. Okay, but if a mistake happens and is stuck in the oviduct, implantation will happen in the oviduct. And when that happens, that results in this type of ectopic pregnancy. Okay, now if you look at the isthmus parts, we have 25%. Ampulla, a lot of ectopic pregnancy happens there. Okay, and then we can even have abdominal pregnancies, as shown in the figure below, and that can happen when there's fertilization and then it falls on the intestines. Okay. Remember that rupture can lead to life-threatening, especially if it implants an oviduct and is growing and the oviduct ruptures. The woman can lose her life. So on your screen is a tuber pregnancy. It has been removed. So you can see some of the trophoblasts infiltrating it. Trophoblasts here, yolk sac formation, and this is where the rupture happens. And we can see a developing embryo in the tube. This is not the place. When it happens like that, we need to cut the tube and remove it. So that is week 1. We've gone through fertilization, day 3, day 5. What happens? Now we're going to look at 7 to 14. That is week 2. Any question? Any question? before we tackle week 2? Any question before we tackle week 2? Good. Let's proceed. Week 2 is also one of the interesting things. I've told you week 2 is implantation. Now, why would the embryo decide to implant at the fundus? Why would it decide to implant at the anterior wall? Why will it decide to implant at the posterior wall? At times, implantation can even happen at the cervix. Why? We're trying to explain that in this particular PowerPoint. Okay? Okay. Now, implantation. You see, why do we need a lot of estrogen to make sure that the endometrium will grow? Why am I even interested in growth of the endometrium? If your endometrium does not grow much, implantation won't be possible. Remember, I told you that the family planning things. I said that family planning is usually progesterone to make sure that your estrogen level goes low and then your endometrium does not grow. That is family planning. Or give you a shot of the progesterone more than the body will need. And of course, that will also allow shedding off of the endometrium. It goes high, it comes down. When it does that, there will be a shedding off endometrium. Okay? Yeah, Cynthia, your hand is up. Cynthia? Yes, go on. Please come again. Cynthia, come again. Cynthia.
Doctor, she said from day 1 to 7 can age seed detected.
Can what?
Age seed.
Okay. Oh, ACG. Okay. Now listen carefully. You see, you've not mentioned any ACG as at day 7. Okay? ACG will start when there's implantation. ACG will be produced by the trophoblast cells. Whilst the trophoblast cells are invading the endometrium, they will produce ACG. The ACG is to tell the corpus luteum to still produce progesterone because they are still there. If they don't send the feedback to corpus luteum to produce progesterone, automatically when progesterone ceases, estrogen will go high and then endometrium will shed off. So whilst implantation is going, the trophoblast cells will secrete ACG, and that will happen from week 2 onwards. Okay? Week 2 onwards. But from week 1, you can't get any ACG. Because week 1 is then that the embryo has moved from the oviduct into the uterus. Implantation has not happened. But once implantation starts happening, the trophoblast cells will produce ACG to tell the corpus luteum to produce more of the progesterone because they are still there. They are not dead yet. That will go on till placentation happens. When placentation starts, automatically progesterone production will be done by the placenta. Okay? So that is the whole idea of ACG. So the hormone that you use to check for pregnancy will happen only when there is implantation. That is why I'm saying that pregnancy is implantation. No implantation, no pregnancy. No implantation, no ACG. No implantation, no embryo. No zygote. Okay? That's the whole concept. Okay? So that is the 1, 2. Now let's go. Yes, Beatrice. Yes, go on, Beatrice. Yes, we are going to go through. Don't worry. We are going to go through implantation. Okay? And we're going to talk about everything. Yes. There's spots, blast spot. Remember that the embryo is going to eat its way into the endometrium. What's eating its way? Endometrium, remember we say we have the functional and the basal layer, and they all have blood vessels. So while eating its way out, that's why at times you can have spots of blood. When you see those spots of blood, yes, it means implantation has happened. Yes. Okay? Now let's go through it. We say implanted embryo become more deeply embedded. Yes. Is there another question? Okay. Now, the embryo is in the uterus. ZP has been removed. So now it's going to decide which part to implant. Okay? But before it does that, now the inner cell mass will transform itself quickly. Let's go through that. Between 7 to 14 days, the inner cell mass will transform themselves. Now let's look at the whole thing here on the screen. Number one, the blue color is showing the trophoblast and the inner cell mass. The inner cell mass at this stage we say is pluripotent or pluriblast. Okay? Now if you look at the trophoblast will come the yellow level. Trophoblast will divide into two: cytotrophoblast and syncytotrophoblast. Okay? And then they'll fall the chorion and placenta and go away. Okay? There. And then the inner cell mass also divide into two: hypoblast and epiblast. Hypoblast will form the yolk sac, and then the epiblast will form the parts that are going to develop the baby itself. Okay? Like the endo, the meso, and everything will come from the epiblast. And that will develop the whole aspect. So for now, we are the blue stage, trophoblast and inner cell mass. Now from 7 to 14, the yellow will come in. Okay? During implantation, the trophoblast will divide into two. We're going to get the cytotrophoblast, that's the inner aspect, and the syncyto will be the external. Okay? We're going to look at it. And then at the same time, we're going to have hypo and epiblast. Remember, when you say blast cells means what? Stem cells, young cells, immature cells, we call them blast cells. So hypoblast means that the cells that are young that are below. Epiblast means the cells that are young that are what? Above. So the inner cell mass now will position themselves into two. And that these two will form two different lines. Okay? And because there are two lines here, we say lamina. So we're going to call it bilaminar disc. So during 7 to 14, we have the formation of the bilaminar disc. That is the hypo and the epiblast. Remember, at the same time, we're going to have differentiation of the trophoblast to form cytotrophoblast and syncytotrophoblast. All that happens between 7 and 14. Okay, so that is the whole. When you look on the screen, we have also 3 stages of implantation. Apart from the hatching stage and the development of the embryo, we have the apposition, the adhesion, and the invasion. When you say apposition, it's an English word. What does it mean? Apposition, an English word though. As I say, apposition. This class is filled with ladies, and you say ladies are good in English. So tell me what it means. Apposition. Yes? Apposition. Okay, somebody just type. Let's see what she typed. It's not bad. Say aligning. Aligning, apposition. Aligning. Who was that? That is Ali. Ali. Okay, apposition. Augustina is also saying side by side. Let's see. It's going fast. Let's go fast. Okay. Mabel. Oh, it's going fast. I can't track. Crisscross. No. I'm not saying what. Apposition check crisscross. I'm not saying what. Yamwa. Crisscross. What is crisscross? Close facing each other. Hey, assembly. I'm not saying what. Yamwa. Crisscross. You crisscross. You know? Okay. Interlocking. Side by side. Okay, I'll go with the side by side, close together, and this. Okay, and then the next stage, apart from apposition, what is next? Look on the screen. We have adhesion. What's that meaning? So the first stage of implantation is that the embryo will lie side by side. You see, the endometrium is there. It's coming closer to it, and this closeness means that there should be something that attracts. Actually, if you look at the molecular level, we have positive, negative attraction. There should be an attraction between the embryo and that particular part of the endometrium. There should be an attraction. And of course, adhesion. What's the meaning of adhesion? Sticking together. Thank you. That is who? That is C2. Is it Ali C2? What? Rueda. Sticking together. So apposition, sticking together. So it comes side by side. When it's attracted to a particular part, it sticks to that part, and then it enters that part. It invades. It eats up in that part. That is where we're going to have the lady is going to get spotting. Okay, doing implantation, when the embryo is eating that part to embed itself, we have spotting, blood coming out, and then the lady can have spotting. Some people can have spotting, some few spotting 1 or 2 days. Others can have it 1 day. Others can even have it 3 days, and then it stops. Those who are not experienced will think that it's menses that is coming. You have implantation. Maybe it happened. Okay. Usually in your panty, you're going to see spots of blood in the panty. That is where we have. It's not everybody that will see it actually. Others won't even see it at all. Others can also notice it. Okay. So implantation has 3 stages: apposition, adhesion, and invasion. Okay. Remember, we said fertilization has 3 events. Now, after fertilization, implantation too, there are 3 events. Something should attract the embryo to align itself there, its molecular base, and it sticks to it, and then eats up its way out. So the details are in here. You can look at it yourself and get the PowerPoint. Okay. Now, whilst eating up the endometrium, remember I said the trophoblast will change. We're going to have syncytial trophoblast and cytotrophoblast. Actually, the syncytial is internal, and the cytotrophoblast is internal, and the syncytial trophoblast is external. Okay. Now, so how does it eat up? Now there are 2 differentiation: cyto internally, syncytial externally. Now, when the cyto is undergoing cell division, the cytotrophoblast will divide quickly, undergoing mitotic division. Whilst it's dividing, it will be pushing the syncytial into the endometrium. While the syncytial too is going, invading the endometrium, there are spaces creating in the syncytial cells. We call those spaces lacuna like the lake. Okay, these spaces are going to allow blood to move from the mother side or from the endometrium into those aspects. Okay, why? Because the aim of the pluriblast or the bilaminar disc is to grow, and when it needs to grow, it needs what? Blood supply. Now the blood supply here are not arteries and veins coming there. It's the syncytial trophoblast. While eating its way into the endometrium, it creates these spaces that will allow maternal blood. I'm offline. God. Let me recast. Okay. So I was talking about the differentiations that happens. Why do we have spotting? And then what happens? How would the developing embryo, that's the bilaminar disc, get its nutrition from? Okay. And I said that once the inner cell mass divide to form the hypo and the epiblast, at the same time, also the trophoblast differentiate to form the cytotrophoblast and then the syncytial. The cyto is the one in the middle. If you follow the cursor here, is the cytotrophoblast. Okay, and then that will undergo cell division, mitotic division, whilst dividing to push the syncytial into the endometrium. So whilst the syncytial is also invading the endometrium by the push of the cytotrophoblast, it also creates spaces within the tissues. Okay, spaces within it. These spaces are called lacuna, and the lacuna is a way to allow maternal blood to move into the spaces. Okay, so we're saying that when this blood moves into the spaces, before they move to the pluriplast or to the developing embryo, they need to be sieved by passing through the cells of the syncytial trophoblast, by passing through the cytotrophoblast before getting access to the embryo. This network of sieves make it difficult for microorganisms, diseases, and everything to pass into it to the baby. Okay, so when you have an HIV patient and then she takes her medication regularly, It means when the viral load is low in her, it will be difficult for the baby to born with HIV. Most women who are doing proper medication for HIV treatment can give birth and then their babies have no HIV. Why? It's not that the blood is not involved. Yes, the blood is involved, but there's a mechanism of sieve that will develop to the placenta or the cord later that makes sure that the maternal blood is sieved, nutrients transfer to the baby without any blood contact. Okay? Between week 2, those spaces in the syncytial trophoblast are called lacunae. They will allow the blood to move through diffusion, and then from there it will diffuse. The nutrients in it will diffuse to the developing embryo. Okay? So understand invasion. Invasion is a radical tool. Syncytial moving into the endometrium like anything else, invading, and then that will happen when a cytotrophoblast is undergoing cell division. So it will be pushing the syncytial into it. While the syncytial is also going into it, it creates spaces to allow maternal blood to drain into it, and then through diffusion, nutrients and everything is transferred to the developing embryo. Okay, so that is what happens during implantation. So these are the details of invasion. You can read for yourself. Okay, so if you look on the screen, we have implantation and placentation, day 8. Okay, and then day 9 we have syncytial trophoblast forming lacuna or trophoblastic lacuna, allowing maternal blood to diffuse into it. And then day 12 we have maternal blood diffusion into lacunae, and then the nutrients in it will be absorbed or diffused to the baby through different aspects. So we have differentiating further into syncytial. Syncytial will be the stem cell population. Cyto will be the stem cell. Syncytial trophoblast will forms the collection, and then we have maternal capillaries draining blood into the trophoblastic lacuna. Okay. So that is the whole concept. So the filtration apparatus is formed right during implantation. There at day 13, we have the developing embryo forming the 2 laminar decks. That's the blue and the yellow, creating the amniotic cavity and the secondary yolk. Okay. And then, so that is how week 2 ends. So a quick recap, since our time is up, I'll quickly recap week 1 and 2. Week 1, we'll start with fertilization. After fertilization, the developing embryo, we call it the morula stage. Okay, morula. 1 will form 2, 2 will form 4, 4 will form. We call those morula. Remember, each cell's form is called a blastomere. And I said at the A stage, we say these blastomere are totipotent. It means they are capable of forming one person. But from 16 ongoing, they become pluripotent. It means from that, either they disintegrate or not, they can't form one person. Okay, they've lost that ability. Okay, now after fertilization, whilst this division is ongoing in that ball, forming a lot of small cells, inner aspect, the cells are moving to the periphery, others are moving to aggregate themselves at one point. The cells moving to the periphery will develop to form the trophoblast, and the cells aggregating at one point to form the inner cell mass. The space left there is filled with fluid that we call the blastocyst. Remember, at that stage, we still have the ZP around it. Okay, so from fertilization to week 1, that's what happens. Then from week 2 is when implantation is going to happen. Okay, now the first step of implantation is when the ZP has to be removed. It will be removed by the trophoblast secreting some proteinous enzymes to digest the ZP. Hence, the embryo will hatch carefully. When hatching starts, it means that implantation is ready. Now, in the 3 stages of implantation are position, whilst the embryo will decide which parts of the endometrium to implant to align itself. There's a molecular exchange at that time. So, baby, I hoya ne dem, okay? Baby, abua, the diko baby na so, okay? We are hoya ne dem, okay? So we have a position lying side by side, and then we have adhesion. They will be attracting each other. Right from adhesion, the trophoblast differentiates into 2 parts. cytotrophoblast and syncytotrophoblast. The cytotrophoblast will undergo cell division quickly to push the syncyt into the endometrium. So it's like they root into it. The rooting aspect or the eating up of the endometrium can be spotting. So the spotting is a sign of implantation, which I said some ladies will spot for 3 days, others 1 day, others will not even see it at all. Okay, good. And then at that time, these cell divisions are important. Number one, why cytotrophoblast is differentiating to push the syncytotrophoblast into the endometrium. Then something else happens. The syncyt also creates spaces within the tissue. We call them trophoblastic lacuna. And these are going to allow maternal capillaries they invade the blood from the maternal capillaries and it to be synced or pulled into the lacuna. When you're in the lacuna, by diffusion, nutrients will diffuse to the baby. And I'm saying this sieve mechanism of a developing embryo is very important. And I even said mothers who take their drugs, HIV mothers who take their drugs very constantly. At that stage, even the virus cannot penetrate that network. Okay, so there's a sieve network, so a baby can be born without HIV this time around. Okay, so there are so many diseases that these sieving mechanism will prevent. At the same time, the inner cell mass also differentiates into two. We're going to get cells that are young and are the top, cells that are young and are below. I mean, epiblast and hypoblast. Okay, by so doing, there are only two cells, so we say they form a bilaminar disc. Okay, up to day 13, the bilaminar disc will even coin themselves, form the amniotic cavity, the secondary yolk sac on the same space. And of course, the big space left there, the blastocyst here becomes the chorionic cavity, which eventually will form a whole space for the developing embryo. That ends week 2. Today, this is where we're going to end. So we end week 2. Next week, we're going to continue from week 3, week 4, week 5, here and there. And we're going to know which organ forms first during next week. Okay? So, during this development, why is a particular organ that midwives are particular to? Why is that same organ the ultrasound people are particular to? It means that organ forms first. Do you know the organ I'm talking about? That's the first organ that forms in there. Okay? So we're going to know when the heartbeat starts next week. And then from there, what organ develops second? We're going to look at it. But there's one organ that the development is very important to the human body, the brain. We're going to look at the development of the brain too, and how it happens from which part of the body to every. In other words, we're going to move from bilaminar disc to trilaminar disc next week. The trilaminar disc, I mean the ectoderm, the mesoderm, and the endoderm. Okay, so that's where I will end. Next week we're going to continue. Okay, thank you for your attention and your participation. Remember, the week is very young. Chilled, but don't freeze, and come back alive next week, safe and sound. Bye bye.